All right. 1. I said stuff on Thursday. I never touched plan book because white day, chaos. Boy, that was a hell of a weekend. So I never updated plan book. And I did not know that until I walked in at 7:20. So, rewind back to Thursday. Words were we didn't finish this. We only had a couple examples left. So we were going to do that was the homework the next day instead. Because we didn't have homework that day. So that was your homework this day. And because I was insanely distractible on Thursday, we did not finish. So that was not our assignment. That's the assignment today.
I didn't do it. So you're telling me I did the assignment for today already? Yeah.
I'm curious how we did the assignment having not done half the lesson.
It was kind of just, it was kind of like the rest of the day. It was like what we did.
Okay.
So, like,
Now, the second half of 2.6 is not difficult having done the first half. It's instead of only finding zeros, you find zeros and asymptotes.
Yeah.
And then you test those intervals. You just have to be careful about your domain, because even if it says or equal to, you can't equal the asymptote. So it's not difficult to extrapolate from what we had done to what we had not done. But no one asked.
I didn't do it.
Yeah.
I'm just straight up.
So here's what we're going to do. I'm not interested in what you have to say right now. We're just going to finish 2.6. And then we're going to have time to do whatever you haven't done. Okay? Yes, 2.6 is the last section. It's a clean break at quiz 6, is the end of chapter 2, is the last score that will go into the grade book for the quarter. And Wednesday we will start 3, which is just a review of logs, so it should be easy. Yes. Yes. So, that's the battle plan. You should have done this. I'm not going to go through homework questions because people did different things, and that is my fault. So, no homework questions. You should have done this. This is assigned today. Regardless, you'll have time in class to do both. So now, that's what we were supposed to do here. I was supposed to change this to say 2.5/2.6 and then move that homework over, and I never did.
See, I thought they were just combined. Yeah, because
Yeah.
you said you would have more problems at 11. So
but then we didn't finish 2.6. We were supposed to finish 2.6. So,
we have like 2 examples.
It's hard to describe this without the word cluster. So, we'll move on to today. Finish 2.6. Time to work on whatever. Tomorrow quiz. Cool? Who's doing PSAT? For you? Okay. Reviews online. Just do it in a notebook. I never look at them anyway. Just so like if tomorrow's PSAT, then just do the review, go through the video. Wow. Do review stuff. Be prepared for quiz. Come in next Maroon Day, Spartan time, do quiz. And because you've already done the review, you should be in and out of the room in under a half hour. Cool? Okay. So, now that we have finished 2.5, go. Well, I'd say about 80% of that is on me. I forgot to change the thing. I assumed I had done the thing. The weekend was atrocious, so I never thought to do the thing. It is concerning that no one asked, though. Now, I get the whole, like, rely on plan book. Yes, this is where you're going to find stuff, but there's nothing wrong with just a quick text that says, hey, is plan book right? And then the next time the child isn't screaming, I'll go and look at plan book and say, oh, no, it's not. Respect the classics. I won't use regular those pencil sharpeners either. I always use old manual ones. And this is kind of a grab bag. It's got 3 or 4 important concepts in it. Who's still going? Okay. Was that a little too much mojo for Monday after a 3-day weekend? Yeah? Okay. We'll just go through it, and we'll kind of do almost a la carte selection for points. Meaning, if you did any of these like 8 or 9 things, get a point. Even if you didn't get to the end of the rainbow, that's okay. Did you do enough things? Cool? Okay. So round 1, I have to factor stuff. Now, I'd put that up there hoping we've talked about factoring by split terms, factoring by grouping enough times. I was hoping we could do it. Probably a little too much right now, but I would take this and split it off, plus x minus 5, or 6x, because then factor out an x, factor out negative 6, negative 6, and you get x. This is x minus 1, the quantity squared. I'll write it separately just so you can see what the next stage is. Minus 6 by x minus 1. If I take that x minus 1 out, I'm left with x squared minus x minus 6, which is itself factorable. So we get x minus 1, x minus 3, x plus 2 as a numerator. Denominator is a x minus 1, x minus 2, x plus 1, x plus 2. There we go. All right. That out of the way. What's that create? Okay. Whole at x is negative 2. What's that create? Vertical asymptote at? Okay. 1, 2, 3, 4, 5. Real quick, I'm going to change my axis here to go by 2s. Just because I know where my oblique asymptote's going to go. Then, what do those do? Zeros, x-intercepts. So I'm going to have x-intercept at +1 and at +3. If I were to plug in f of 0, 0, 0, 0, 0, 0, get a y-intercept of 3. And how, oh how, do I get my horizontal asymptote? Okay, leading terms, check their degrees. Degree on numerator is greater than degree on denominator. So I need to divide. Now, we've got 3 ways we can do that. Option 1, just straight up long division. Option 2, synthetically divide twice, a la Paul. Option 3, because I've already canceled out a factor here, and I know there's a hole there, what I should be doing is probably synthetic division off to the side using this. So -1 into x squared minus 3x minus x is minus 4x. -3 and -1 is +3. That doesn't need to be there. 1, 1, -5, 5, 8, but we don't care about the remainder. Y is x minus 5. -3x minus x. So this numerator, if not factored, is x squared minus 4x plus 3. I think that's where I went too much. Combining, finding the zeros and having to do the synthetic at the end. That was too much. So if I have minus 5, wait, no. Up 1 over 1, up 1 over 1, be careful, up 1 over 1, up 1 over 1, my scale is different. Down 1, back 1, down 1, back 1, down 1, back 1, down 1, back 1, down 1, back 1. Oblique asymptote. If you want to go find some extra points, you go for it, but I see that we're coming down through the y-intercept, x-intercept, and off, and it's going to do kind of the same thing down here. Okay. So here's going to be just our grab bag of possible points. Did you get x-intercepts, y-intercepts, vertical asymptote, oblique asymptote? Did you even attempt dividing to get said oblique asymptote? Did you mark your hole, which I did not? Black, black, there's black. Somewhere down there. You know what, better yet, I'm actually going to add that in. Did you mark it? Did you find it? 1, 2, 3, 4, 5, 6, 7, 8. Do you got the work to back up how you broke up your numerator? does your graph look something like that if you got all the way. So there's 10 things there. I'm going to say everything you did up to 5 is a point. So if you did at least 5 of those things correct, 5 out of 5. Okay? I shouldn't have tossed that much at you. Having seen the full process, though, we don't like it, but if you had, I don't know, a quiz problem where instead of 6 problems on your quiz, maybe you only had 4 problems on your quiz, but that was one of them because it involved that many different pieces, could we do it? Okay. So, no, God, no, I don't do that on quizzes.
That's the one thing that I would like to messed up on is I just couldn't figure out how to split it, and then I split it wrong.
Yep. All right. So, like I said, I goofed. That's on me. This is what you should have done over the weekend. This is what gets assigned today. Collectively, the two should be done tomorrow. Sounds like some of you did a little bit of each, or one or the other. Oh well. Let's finish off the last few on 2.6, and then you got time to work. Okay? 2.5, 2.6. Oh, okay, that's what it was. We did the special ones. Right? So, part 1 was I solve an inequality by finding its zeros. Once I know the zeros, if it's a polynomial, I'm able to just look at n behavior and I can tell what it's doing with them. So I'll know if it like comes up like this and like this and like that. Then end result, if I'm asking where a function is, say, less than 0, you literally look at where is it below the x-axis. And then you write them as intervals. Cool with that. Okay. Be careful when you do those, because if it's or equal to or not, can really affect your answer. Because remember, what about those ones where it's like this? Say it's, I don't know, 5 and 9. And I ask, where is this function less than or equal to 0? Right? Less than 0, so negative infinity to 5, parenthesis or bracket, union, just 9. Yep, because it's a singular location, not an interval. All right. What if I took that same thing now what? 5 to 9, 9 to infinity, because you have to exclude that point because it's on the x-axis and it is not greater than 0. Okay, so that's where we left off.
down at 3C.
Oh.
Because we were at
And 16, 1, so that's x minus 1, the quantity squared. Same thing, 5, negative 5, half 1, squared, 5, negative 1, plus minus 2i. Okay, so if I was going to solve each, imaginary zeros means for 3a, 3b, you've got a parabola that's floating up here. So if I ask, where is that thing greater than 0? Everywhere. Where is that thing less than or equal to 0? Never. Okay. 3c, 3d factors into x minus 1, the quantity squared, vertex form. It'll have a 0 at 1 and bounce off the x-axis like that. So if I ask, where is that thing less than or equal to 0? Just 1. Where is it greater than 0? Everywhere else. Okay, so those were our special ones. Sometimes you get weird stuff. Just look at the graph. So I know we're kind of in a weird situation because some of you just kind of inadvertently figured out the rest of the lesson to do the assignment that we weren't supposed to. Oops. Show me thumbs. You cool with that? Like polynomials and special sets. Okay. So the only thing that was different about rationals is a rational graph can switch between positive and negative to cross that boundary of 0 at X-intercepts like this, but it can also change at asymptotes. Because right now, say I've got that, well, what happens if, stop that, if it's that instead? Okay, because now, if that's my axis, it switches from negative to positive at an x-intercept, but then it goes from positive to negative at my asymptote. And then it goes from negative to positive at my asymptote and positive to negative at my x-intercept. So I've got two different things that can change whether it's positive or negative, both zeros and asymptotes. So just find both and test both. Make that little cheater number line and test the intervals in there, but you have to find those first. So when I say this is greater than or equal to 0, y'all cool with y? Wow. If I'm asking where it's greater than or equal to 0, I'm asking where are the y's greater than this thing? Effectively, because you're going to put 0 in for y. I did that backwards again. Yeah, I did. I did it right the first time. Boy, it was a weekend. So, I need to go find all that stuff for this. Ew. How do I do it when they're two separate parts? Common denominators. X plus 1, x plus 1, x minus 6, x minus 6. Upstairs, 4x plus 4 plus 2x minus 12 downstairs, x squared minus 5x minus 6. Six x minus 8, x squared minus 5x minus 6. Okay, so I want to know where that is greater than or equal to 0. Not or equal to, just a...
I have a question. Why don't you just leave the bottom factored so that you can just know what the...
So that I can ask this question. Whenever I have a polynomial, what is the first thing I should do?
factor?
So if you wanted to leave it as factored, that's fine. Okay. The reason I wanted to do that so you see the entire thing, you know you still have to go back here and say 3x minus 4 over x plus 1, x minus 6. What's a reason that I would want to factor it? Like there's several, but why would I want to leave it factored?
Because you don't have to factor in the other stuff.
Okay. I would want to leave it factored so I can find my vertical asymptotes because they're going to be part of the numbers I'm testing. Why would I want to multiply it all out? So I can get that y-intercept, right? Because now if I plug in 0, I see 8 over 6. There are benefits to both. If I see f of x is 6x minus 8 over x squared minus 5x minus 6, f of 0 is very easy to find. Just shove a 0 in for the x's. Negative 8 over negative 6. I know that I have a y-intercept at 4/3. If I see it in factored form instead, okay, I can either factor it like this or I can factor out the 6 entirely. Both are beneficial. You know what? I'm going to do all three ways. There we go. This way I can easily find my y-intercept. I'll also easily see my leading coefficients if I have same degree. I'll also be able to do synthetic division or long division if I need to find an oblique asymptote. Leaving everything in simplified form has its uses. Leaving things in factored form also has its uses. Like finding x-intercept at 4/3, finding vertical asymptotes at x equals 6 and x equals -1. The way I can test this is that number line. I know I'm going to have an x-intercept at 4/3. I know that I'm going to have vertical asymptotes at -1 and at 6. Those are the three places where this thing can switch between positive and negative. So option 1, I test the intervals. I manually pick numbers in those spots and test. I shove a -2 in there and see what happens. So -12, -20, 4 plus 10 is 14 minus 6, so it's a negative number. Okay. I shove a 0 in there. Oh, look, 4/3. I shove a 2 in there. 12 minus 8 is 4. So 4 minus 10 is negative 6. Negative 6. Oh, hey, that's a negative number. Stick a 10 in there. And so on and so on. Or, and come over here, just type it. And we had 6x minus 8 over x squared minus 5x plus 6? Minus 6? And I could test it that way. Say at negative 6. It's a negative number. Okay. Somewhere in between negative 1 and 4/3, 0. Oh, hey, it's positive. Cool. Somewhere between 4/3 and 6. It's a negative number. Somewhere after 6. Okay, I can test it that way. The reason that I'm breaking all that apart is because we just spent all this time on how do I graph these. You could just sketch the graph now. Because you know where the asymptotes are. You know where the x and y intercepts are. And if you're able to sketch the graph like that, even if it's on this little cheesy number line here, maybe instead of this, I just know how the graph looks. If I know that I have a y-intercept of positive 4/3, then I know it's going to go through there and have that alternating behavior. If you know the graphs well enough, you don't need to test the intervals. You can just quick sketch like this, and now you know your answer is, well, it's negative here, positive here, negative here, positive here. I'm trying to give you options. You can do it by graph behavior. You can plug in and test manually and just look at the screen. Okay, however you're going to test it, you're going to know where it's positive and negative. I want to know where that thing is greater than 0. Greater than 0. So negative 1 to 4/3, parentheses or brackets? Parenthesis here because it's an asymptote. Parenthesis here because I can't actually equal my x-intercept.
Because it's saying, is it
Greater than, not greater than or equal to. That's the catch. Union 6 to infinity. So that's why technically you only need the number line. But if you know what the features of it do, then it can help you to get through the behavior of the graph to know what's positive and what's negative. Okay, I'll do it again. Baby steps. How do I start? Subtract 1, everyone on one side. If I'm going to do that, I would do well to instead say plus a negative 1, just so I remember to distribute a negative with my numerator. Because negatives, you know, the bane of the math student's existence. Then get common denominators. You're missing a 4x minus 3. Distribute, combine like terms. Negative 3x, 6x plus 3 is plus 9, or 6 plus 3, over 4x minus 3. So this is simplified form. I always want to have a factored form with it to see if there's anything that can cancel. Now, most folks probably aren't going to want to do this. Because I know my vertical asymptote is at 3/4 now.
So why don't you just know that and like not do that?
I mean, you can also just solve for 0 here, right? Just shown both, because what if there was something that could factor out here? What if what if that was a 12? If that was a 12, then by factoring those out, I would have seen that the x minus 3's cross, and it's literally just a horizontal line with a hole in it. Okay, so I always want to have my non-factored form and my factored form to compare them because they both have their merits. Now that I've done it, my graphifa has a first name. It looks like it. I've got a vertical asymptote at 3/4. I'll have an X-intercept at +3. Anything else? If I was going to quick sketch it, I would have a y-intercept at -3. I would have a degrees are the same, leading coefficients, horizontal asymptote at -3/4. Do you see how that behavior informs the rest of the graph? Like, I don't have to test numbers if I know what the graph does. Because now I know, just by the behavior of the graph, if I've got a y-intercept down at -3, that means on this side, it's going to be negative. I have an x-intercept up here, and this has that alternating behavior around a set of axes. I know it's going to be positive. If there's an x-intercept, that means it crossed through and is now negative. Or I just do this. Grab my calculator, test 3 points. I'm trying to give you options. If you understand the behavior of the graph, you don't need to do that. If you don't want to think about the graph and just want to press the buttons, do that. I know that it's negative, positive, negative. Ta-da. So, where is that greater than or equal to 0? Why is it parenthesis and then bracket?
You can never touch an asymptote.
Okay. I can't equal a vertical asymptote. That's a gap in the domain. So even though it says greater than or equal to, since I can't equal that gap in the domain, I have to have a parenthesis there. That's also another benefit to not just putting numbers on a number line and testing, but if you know the behavior of the graph, hopefully you'll catch that. I've always preferred doing kind of a hybrid like this, doing a little dotted line to indicate this is a asymptote, this is an x-intercept. Norf! That way, I don't know what just happened. I just heard someone who was loud. If I have a asymptote, I know that I can't equal it. But if I have that little dotted line there to indicate it's an asymptote instead of an x-intercept, hopefully I'll remember that and not make the mistake. Okay? So, Start one that's small. Okay? This one's not bad. I want to go through B together because it involves a oblique asymptote. It's just like when we did our continuity test. We don't have to write a crazy load of stuff, but we have to have the experience with it to understand what's important. So we're only writing the important stuff. That wasn't you guys. That was okay. Wait. Uh-huh.
So my thought right off the bat was, well, I can multiply it by x and also multiply it by x plus 5, right?
Uh-huh.
And then I have x plus 5 is greater than x, which is a true statement. But then I didn't know what to do from there. I don't know what it is, but if you subtract x over, then you have no x's.
I don't know.
And then you just get 0 is greater than 5.
Okay. Remember, this isn't just about solve the inequality. It's about find x-intercepts and asymptotes. If you say I'm going to multiply both sides by x and x plus 5, respectively, remember what you do to one side and do the other, so you're actually going to be multiplying both sides by x squared plus 5x.
Right.
B, that only gets you x-intercepts. You still got to keep those asymptotes in mind.
Okay. I understand.
Okay, here's what I mean. I'll get x plus 5 minus x is just 5. Okay. Zeros of the numerator create x-intercepts. Set 5 equal to 0. There is no x-intercept. That means it just never crosses the x-axis. So when I make my little number line here to test, the things that I'm testing are the asymptotes at -5 and 0. You can't just solve, because that only gets you x-intercepts. We have to test around both features. If I was graphing this, I would have at 0 and -5, I have a horizontal asymptote at 0, hence no x-intercepts. Pick some numbers, plug them in, I don't know. Say I put in a 1, that's positive. Put in a -1. Also, no, that's a negative. Put in a -6. Positive. Okay. So if I know my behavior of the graph, and I know it does this, I see, yeah, it never does hit the x-axis. There are no x-intercepts. There are no zeros to be testing. But I know it has that behavior. And so then I ask, where is that greater than 0? From -∞ to -5, parenthesis or bracket. Double dose, because it's not equal to and it's an asymptote. Union 0 to infinity. You have to test both, which is why you need to get it in this form, because then you'll see x-intercepts and vertical asymptotes. That's why I need it in that form. I can't just cross multiply off the bat and go for it. You have to have the combined form of it.
And just to be clear, the opposite of that would be -5 to 0. Because you can
If it said greater than.
like you can move it to the other side.
But if I do, everything's negated.
And then 0 is greater than -5. Yes, because we do the exact same. I'm just asking for.
Okay, yes.
Just making sure that that is correct.
So x minus x is gone, -5, x. Most kids don't like that form, so we'd flop it around. It depends which side you went to. It doesn't matter. I still have -5 equals 0 to make my x-intercepts. There are no x-intercepts. Asymptotes at 0 and 5, or -5. If I were to test this, it's going to have the opposite graph with that, but the inequality is also backwards. Now it's asking where is it less than 0, and it's still going to say -∞ to 0, or 5, and 0 to infinity. So the math law works. Doesn't matter which direction you go. You might have a different graph, but you're going to have the same answer. What happens when we get oblique? Everyone to one side. Minus 3, 0. If I see -3, it would behoove me to say plus a -3. Missing a x minus 2 for a denominator. Distribute and combine like terms. X squared minus x minus 3x. -11 positive 6. I have my regular form, get the factored form. The three features I need to test: vertical asymptotes and X-intercepts. So I need to test at -1 is an X-intercept. I need to test at +2, which is a vertical asymptote. I need to test at +5, which is an X-intercept. You could now just plug numbers in. Plug in -2, plug in 0, plug in 4, plug in 28. And just see, are they positive or negative? That's it. That's all you have to do. What I want you to be aware of is you can use the behavior of the graph to answer that instead. I know my y-axis is at 0. I know that I'll have a y-intercept at +5/2. So if I have a y-intercept at +5/2, I know that it's positive right here. This is an x-intercept. If it's positive here and there's an x-intercept, I know it has to go through that and be negative down here. If there's a vertical asymptote, because these things always alternate, I know that it's going to be negative down here. This is an x-intercept. It goes through there. If you know the behavior of the graph, you don't need to test, but you have the option. That's what I'm trying to get across here. You have the option. If you know how the graph works, you can just quick sketch like I did because I know the behavior of the graph. If you don't want to do that, then just press buttons and get answer. I could quick sketch like that, or I can come all the way back here, plug that in, x squared minus 4x minus 5 words minus 2. I actually temporarily went blind there.
I honestly didn't know what you were saying. My brain just shut off.
Same. Clear, 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 clear. Enter.
Just right over here. Yes.
There you go. Test on those different intervals. Test back at -2. Okay, it's a negative number. Test in between. Test after -2. 3. Test after 5. Negative, positive, negative, positive. I can do it that way, or negative, positive, because I know the behavior of the graph. Yes, there's an oblique asymptote in here, right there, and that's where it's curling along the asymptote, but it doesn't matter. I was looking at the x-axis. Okay. Oh, suppose I should actually answer the question, less than or equal to 0. But because it's an x-intercept, bracket, -2 at parentheses, and then, did I just hear the word negative? And
No, she said negative.
oh, okay. I'm just making sure that I'm not hearing things too. My vision is intermittently going out, so I want to make sure I'm not also hearing things weird. So, there we go.
Are we not doing these?
We will. Can we? I don't care if you like it. Can you? Everything to one side, get common denominators, find your x-intercepts and your vertical asymptotes, test them. Okay. I know you can do it. Can you write it?
No. Yes. I did the homework one. I did it right.
Okay. Then take me on a journey, my lady.
It took me a long time.
Okay. Group of high school students going to rent a bus. You legally cannot do that. For $600. You know, that's one of those random things that no one ever tells you, like the different legal barriers. At 18, you're a legal adult, you can do a bunch of stuff. At 21, legally you can drink in the US. After 21, you're like, there's nothing left. Not true. You can't rent a 15-passenger van until you're 25.
What if you have like?
Oh no, you can rent them. You can't rent anything that would normally require a Class B license.
Could you buy it?
You can buy it, you just can't rent it. It's because of the insurance companies that go through. Basically, they don't want a bunch of frat boys getting a 15-passenger bus, getting hammered, and then running it off a cliff.
Ooh, that's
Okay.
a great time.
So, all right.
Can you rent a bus and a driver?
That you can, because then the insurance is with the driver who is an employee of the company. Okay, so
That's like a limo.
yes. I only know it because I had to rent one when I ran the group home in Arizona, and at the time I was only 22. So, a group of high school students is going to illegally rent a bus for $600 to take to an amusement park the day after prom. Okay, does anyone do road trip to Six Flags after prom?
Definitely in the middle of South Dakota.
You find a parent who is willing to, and then you all pass out on the way there. Okay. The tickets to the park are $60. That's ridiculously cheap. You've been to Disneyland in the last 10 years?
Never been to.
Isn't it like $150 to get in now or something? It's bonkers. Okay, $60 less an additional 50-cent group discount per person in the group. That's hard to wrap your head around. Okay, so the cost. The cost for each person. What they don't say in here, and this is a poorly worded question, that $600 is being split. It's not one kid is going to pay $600, although the rich kid should. It's they're going to split the cost of the bus. So the cost for every person is going to be $600 split among how many kids are going. And then they're also going to have to pay, each kid pays $60, but that price goes down 50 cents for each person who's in the group. Okay? Your share of the bus, your cost of the ticket. Anything else? That's it? Oh, there we go. Determine how many students must go on the trip for the total cost to be less than $40 per student. Apparently, there's a kid who has exactly $39.99 in their pocket. Like, I don't care, like, if you find a sticky penny out in the parking lot, too bad. He said under 40. So.
That's insane. that has to be 40 kids just for the amusement park to be less than 40. It's a big bus.
Well, let's find out. Who said it? Plug it in a calculator. Okay. Clear. So I've got 600 over X, your share of the bus, plus 60 bucks minus 50 cents per kid. So like if you get, I don't know, what, 20 kids go, then it's going to reduce the price of your ticket by 10 bucks. Okay. Who says you're friends? It just said a group of students. Okay. Well, maybe they're doing that because they plan on spending the other $180 that they happen to have on, I was going to say on funnel cake, but, or those giant turkey legs. Okay. Okay. Now I can put that into Y1. I could put 40 into Y2, find the intersections. Or if I just subtract 40, what should be left on the other side? 0. So if I just subtract the 40 over, instead of finding intersections, I can find the zeros. So I'm going to hit graph and just see what happens. I'm betting I won't see what I want to see. Nope. So window. What is X? The number of kids. How many kids could you pack in a bus? Not less than 0. That is correct. That is a correct statement. We cannot have negative kids in the bus.
So how packed is this bus going to be?
It says after prom, so I'm assuming that you're looking at like 2 kids per seat. This isn't elementary school where you can cram 3 to a seat. Okay. So 2 to a seat. Okay. What's the last time you were on a bus? They always have the little sign in the front that says maximum occupancy. 60, 80? I don't know. Okay. I'm going to say 60 and see what happens. Y's. What is Y in this? The cost. I'm going to say -1 just so I can see the x-axis. And then the cost, we wanted it to be under 40 bucks a kid. I don't know, just do like 50 and I should be able to see stuff. Well, there you go. Right? Maybe I'll go a little bit further. Okay. So I will calculate my 0 somewhere between there and there. Yeah. 60. You get 60 kids on the bus, you'll get everyone's individual cost down to under $40. Oh, wait. We need to pay attention to the wording there. We want it to be less than
61.
Right? Because at 60 kids, it is 40. At 60 kids, it is 40. That one pedantic jerk with $39.99 in his pocket is throwing a hissy fit when there's 60 kids. He wants it to be under. How many kids need to go? 61. We used to do that. When I first started teaching, y'all know it's not Six Flags, Valley Fair outside of Minneapolis, St. Paul. We usually would take our entire sped caseload for the entire building. And unless there was anyone who had any behavior issues, we would just pack up all of our special ed kids, throw them on a bus, and head to Valley Fair at the end of the year. And it was so fun. And I was also very aggressive, so I would make sure like they would be accessible. My kid with cerebral palsy, who was in a wheelchair, oh yeah, you're going on the giant swing. Like you will stop this ride and you will let him on. And we got him on, and it scared the bejesus out of him, and he had a great time. It was great. So, oh, it was fun. Like I got him in the go-karts with me, everything. Like if you're gonna go, you're gonna go. Anyway, we got a little bit of time left. Both assignments due tomorrow. It sounds like a good chunk of you did one or the other. So if you didn't do both, then you're really in trouble. Tomorrow will be a quiz. I'm going to tell you ahead of time. I will have 3 or 4 quizzes, so all 87 of my students quizzing tomorrow. It's also the end of the quarter. I'll just tell you right now, Wednesday's a FUBAR day. Okay? Quiz tomorrow. Wednesday's a FUBAR day for you to leave me alone so I can grade. Fornicated up beyond all repair.
So can I just come here and take a test?
No. Because walking out of the room on a FUBAR day is a bad idea.
They weren't listening.